Hey everybody, it's Adam from Tested.
And it's Norm from Tested.
Now, I just spent some time talking to Phil Tippett about the reanimation, as it were, literally and figuratively, of the Dejarik holochess sequence from Star Wars. And we talked a little bit about the painstaking process of animating these figures in a similar way as he did for the original Star Wars film. But we didn't talk about the fabrication process.
That's right. And for stop motion puppets, fabrication is such an important part. And the technologies they're using for the stop motion puppets in this film are amazing, the recreation of the puppets. So today, we're going to talk to some of those fabricators, including one of our friends, Frank Ippolito, who worked here at Tippett Studio in making these puppets, to learn about that process.
It's the coolest part about the process of the internal armatures for the stop motion animation figures is that it has a lineage going right back to the complete origins of stop motion animation to Willis O'Brien's King Kong armature. You can actually trace the engineering right from there to what these guys are doing with some of the most modern technology possible.
So join us. Hey, Chris.
Hey, Norm.
Hey, Mark.
Pleasure.
So Chris and Mark, you guys, a visual effects supervisor and art director on this project, kind of the digital and the practical ends working together. Can you tell me when you guys were when you landed this project, how did you guys decide how to map it all out?
Well, Phil came to us and told us about the project, and of course we're super excited. It goes back a little further than that, because for the last 4 or 5 years I've been helping Phil with Mad God, and so that has brought stop motion back to Tippett Studio. And we come in on the weekends and we work on puppets with our hands, and this was an opportunity to work on a visual effect for big feature film, Star Wars, using stop motion.
And it's still considered a visual effect. There are some digital elements. You're using digital cameras to shoot it. There's some light processing, but there's a whole tangibility aspect to it. And you wanted to go back to the source. So Mark, you and your team spearheaded the way to recover as close to the original and the models as possible. Mm-hmm. Now, Adam chatted a little bit with Phil about this, but what were the conditions of the models? Where did you find them?
Well, first and foremost, that was our biggest worry, is that in recreating these things, we'd have to figure out where they are, what they're doing. There's that initial sense of panic that we had, where it was just like, oh, great, we're going to do this. How are we going to do this? And so we just started this. It was almost like archaeology, trying to figure out where these things were. Phil had been good about keeping one of his armatures from the original. And also someone here, Nikita, who works with us, was really good about she just kind of dug into the internet and started looking around, contacted the archive, and they just happened to have something that Phil had given to him years and years ago and put on his desk, 4 of the characters on a little miniature chess set. And that was our starting point. We had a sense of scale. And that's when Simo kind of came in. He's like, what we should totally do? We shouldn't sit there and try to sculpt this out with clay or whatever it is, because it'll take forever. Let's use the resources in-house and do some photogrammetry and go and get scans of it. And that was really his front. And that made it real at that point, where it was like, this is practical. We'll be able to get them as close as humanly possible.
Yeah, and what was great is when Phil first heard about this, he talked about how they originally did it. He's like, we'll just spend a few weeks and we'll sculpt them, and some will be out of Sculpey that won't move, like how he did it originally. And we, of course, wanted to take it a little bit further. And recently I had been working with photogrammetry, and the power of that is pretty awesome. You just take an object, rotate it 360s, and shoot it from different angles. And then you get a rough model to start with. Mm-hmm. So when we heard Lucasfilm Archive had the chess set that Phil and John Berg made for George with 4 of the creatures, I think Hunk, Mr. Big, Crouch, and Worm.
Yeah.
So we went to Lucasfilm Archive and set up the photogrammetry rig and shot it, brought it back, digitized it, and were able to show a rotation to Phil, and Phil was super stoked on it.
And not just point data, also color and texture.
Absolutely, because it takes the images and creates the rough mesh and then projects the images back on that mesh. So all of a sudden we were seeing this 360 rotation, so we didn't need to just model it based on photos. We actually got to bring it into a computer rip the characters off the chessboard, because if we were to move those characters that were on the Lucasfilm archive, it would just have crumbled, like, you know, Dorian Gray style, whatever.
Yeah. They were in like really precarious position, you know, and also we, you know, one of the things that was problematic as well is, you know, for the case of the big guy, which is like, you know, the main guy who like body slams in the first one, his head was twisted underneath. He was originally like holding up the guy like this when they gave the statue to George Lucas, and then over time, it just slowly crushed his head to the point where he was almost twisted into his body. So then we had to take those scans, bring them into ZBrush. We used the photo data, which was invaluable to be able to recreate a lot of the details because it projected it. We were able to project that onto the Geo and then go in and match even where all the lines and wrinkles were. So it was just a totally invaluable tool, and we just kind of built them from there. The ones that we had were done that way. 2 others were real scans, pretty clean ones. We only had to clean them up a little bit, and 2 others from scratch.
So 3 different processes, building from scratch, you know, a really high precision traditional scan, and then also using something new, photogrammetry, which is a technology pretty much accessible to everyone.
Absolutely.
But then having different assets, different reference to build your final ZBrush models.
Mm-hmm. Yeah, and it was great because we had the 4, and so we were missing a few more, and we didn't know where they were. And then we found out that Peter Jackson had 2 of them. He had Violet, which is the elephant skeleton thingy, and then the dude with the claws like that. And Weta was cool enough to scan them for us and give us the digital scans, which were really clean and nice.
Big up to them. Yeah, they were really helpful.
Now, Mark, you also worked on the digital modeling team to help polish those models and build 2 of them from scratch. When you're designing that, you know, you're not sculpting with the hands. You've sculpted before, but how did that process work, and what type of attention and detail did you have to pay to that when you know it's going to be something that's going to be eventually turned into a tangible object?
Well, that's one of the things too we had to be mindful of is doing the 3D printing. You have to, your sculpt almost has to be grotesque in the computer. You look at it and it's like the lines are super janky and jagged and pushed in, but you lose a kind of like it's almost like a generation when it gets printed out. So one of the first ones that we printed out was this little guy here, and when Frank Ippolito got it, he asked for us to splay the legs out. So we actually had the chance to kind of jam the whole, you know, really exaggerate it and print it out with deeper detail. And that was kind of a learning process as well. But, you know, like the modelers we had here were great. It was really important for us that we use the resources that we had in-house. We'd love to bring in sculptors to sculpt these things, but we have modelers and they're all like, you know, they're good at what they do. And we were able to give them these things. There was Mark Estrada, Jack Kim, and Will Kalkenis, who kind of came in on this. I got to do a little sculpting myself, but they did the lion's share of stuff. And they just, I mean, they did such a great job. I mean, I'm really proud of the work that they did, because when you put these guys up against some of the original photos or whatever it is, it looks like they've even embettered them a little bit. They look better than, you know, like in some cases, because they got to like go in and put in some fun little details. So it was fun.
And then you, of course, talked about 3D printing. So that was the next step after you had a model that you were satisfied with, that met the requirements of building an armature inside of it. You went and printed it out. So can you talk about that process?
Well, what was really cool was utilizing, you know, the digital technology, because we wanted these things to last, and we wanted to be able to replicate them and build multiple versions of them, and that technology allowed us to do it. And like Mark said, the digital sculptors would go in there, and then we'd have them add more detail and stuff to really get the 3D printing to pop.
Now, is this the same scale as what was used in the original?
As far as we can tell, you know.
exact
But
same
we actually, this guy, Phil, was really good about keeping his original armature, which I think we have around somewhere. He's very good at, like, once he animates something, he wants to reuse the armature. So he took the original armature out, put wire in, And so that actually gave us a really hard and fast kind of like scale, because we wanted to make sure that when we built new armatures, it would fit inside of the of the puppets after they were made. These are the armatures right here.
Wow, so-
and
Yeah.
you can see old versus new.
Yeah, this was the original. So we knew that this armature was in that creature. So from this armature, all of the other characters were built to scale. This was our little litmus guy right here.
And because you're also designing a model that can be tweaked, when you print it out, like you said, you can flatten it, so you know that when you go into the molding process, it's going to get the result you want. It can be as detailed. You can hide the seams where you want them to.
That's true.
That is very cool. So you ended up with literally these guys. You
Yeah.
service to 3D print them out. They're high fidelity 3D prints. Maybe not archival quality, but what's going to happen is that this then gets turned into a puppet.
Yeah.
So let's literally take these guys into the fabrication room and talk to the guys who cast and painted these.
Perfect.
So we're taking this guy, the 3D print of Mr. Big, and we're bringing it to the mold room at Tippett Studio, where we find Frank Ippolito. That's where you've been hiding. Frank, you work to create the molds for these puppets.
This has been the hardest year of my life, not talking about this project.
Well, take that, breathe, that sigh of relief, because you can finally talk about it.
Finally.
And I want to hear about it. So you got these 3D prints.
I got these 3D prints straight out of the printer. And the first thing I did was assemble them. Like Mr. Big, it was like a head. I think his arms were separate, and then upper and lower torso. Glued them together just with some super glue, and then hit him with a primer. And that's it. Like, I did nearly nothing else. Maybe a little bit of patching on some of the seams, but most of it was just perfect right out of the printer.
Wow. When you get a sculpt to mold, what do you look for? Like, what positioning do you look for when you want to create a mold?
Well, you want something that's in an easy enough pose that you can have your parting lines not like all over the place on different planes. So most of the parts came to me like really easy and ready to go. So I didn't have to ask for any changes. Crouch, I asked for them to reprint just because his legs were a little bit too scooped. It would have been hard to register parts. And then there was still a couple of them that they hadn't finished outputting when I started on the project. So I was able to collaborate with the sculptors and tell them what pose I wanted them in. And actually for the one that was the most complicated to mold, I'm glad that I was able to kind of tell them where I wanted the position.
It's one of the benefits of them working with digital assets, models that they can tweak,
Yep.
and 3D printing, they can just reprint one out
Yeah.
and just build another one. So these are the actual molds.
Yeah.
You're going to open one of these up. What type of mold is this?
These are epoxy matrix molds, and on the inside is silicone. So when I first got called up about this project, we weren't sure if we were going to do silicone puppets or foam latex. And so I wanted to make something that would work for both. And then also to be able to pull masters out of in case there needed to be other assets pulled or something like that. So I wanted something I could pull a hard piece out of, a silicone piece, or a foam latex. And so I landed on this kind of rigid silicone from Smooth On. It's called Sorta Clear 37. And I molded just about everything in that, from these big matrix molds to just simple cut molds like this for some of the smaller pieces.
And this type of, this large matrix mold that's really durable, you can mold and cast really big figures out of this. And of course, there's armature that lives in here. So that's why we have Brett Foxwell here. Brett, you made the armatures, you machined them. Now, we have this display here which has an original armature. What was your approach in designing the new armatures?
Yeah, this was the original armature. Supposedly it was the very first armature that Phil ever made, and it's a good armature, but not great. And it's more of just like stamped metal pieces and strictly just ball joints. The new one that I made, which copied the joint dimensions exactly just to keep the scale consistent, was a little bit heavier duty, and some of the pieces I used were some of the Phil had just some modular ball joint pieces, some of which were 20, 25 years old, and then other pieces I built new from scratch. And it all of the joint building involves like starting with just raw stock of tool steel and then just cutting them down to the shape and the size, putting the ball cups in, getting the threads cut, and it's all going to be very. The tolerances are very high, just so the feel is right. So it's adjustable. The different animators want different tensions, and and then just at different points of the walk, like the leg that's moving is looser, the leg that's holding the whole thing up. Sometimes just the one ankle joint has to hold the entire thing up at the end of a stride.
Right. If you think of these as these skeletons for the puppets, it can't be uniform throughout. There's different joints, different materials, like you said.
Yeah.
There's more tolerances at some point if you know beforehand if it's going to put all its weight on one part of the body.
Yeah.
Can you describe the different types of armature connections and joints?
Yeah. So the very basic armature joint is a ball joint, as you can see here. It's a ball and then the corresponding piece has two ball cups that seat on it, tighten down with a screw, and then just give you a full range of motion. And it is the tension is adjustable, and oftentimes in the middle of a shot there'll be a little slit cut in the silicone, and then Allen wrench will go in and adjust it in the middle of a stride. And then also just the different animators. Some animators like things very loose. Some want them with a lot of very, very tight, with a lot of tension.
And then for something that's a little more flexible, like what is this?
This is a wire joint. So these are the fingers, which
These are the feet.
oh these are the feet.
These are
sorry.
feet of Violet, I think.
And then so this is a wire joint, which gives you it's much smaller. It's very difficult to make ball joints this small. The wire will break eventually if you go through too many cycles. And then the other type is a hinge joint, which is this here.
For rotation.
Yeah, for rotation. And often the shoulders will be split into both a ball joint and a hinge joint, just so you can separate the tensions to get even uniformly loose tension. The shoulder needs to be built in two components. And it gives you just a better range of motion. And sometimes you want tighter tension on the ball, but then less tension on the swing, so that the arms can swing easier.
Now, as a machinist and armature designer, what tools are you using today to kind of map this out? Is it just sketches? Are you using CAD tools?
No, it's pretty much the same as it's always been. I mean, there are newer machine tools, but basically I used Phil's shop, which is pretty much the same shop he's had for, the last 20, 30 years, which was quite an honor to use the same machines that these other guys had used. But no, really, with this one, the Mantellian Savrip, it is.
You got the real name out of these guys?
That is the real official Star Wars name.
I don't even know what these guys' names are.
I was the only one holding the cannon on this one. I copied the joint distances. Now the actual configuration of the joints was a little more complicated, and Phil's original just had ball joints, whereas I incorporated the hinge joints in it as well. But the joint to joint distances are all exactly the same. And then it's just kind of, I do some basic sketches on paper, but a lot of it's just, it's in my head, all the basic parameters. And for ball joints, or for armatures, it's kind of a balance between the strength of the armature and how much weight it can hold, and how tightly you can tension them down, and then the size of the joint itself, because sometimes, especially around the ankle, I mean, this guy, he looks like he has kind of fat ankles, but it has
not
to
a lot
hold,
of space there.
Not a lot of space there, and it has to hold this whole guy,
Yeah.
the armature and the silicone casting. So it's often a balance of strength versus size of the joint. And then also the other adjustable part is the range of motion. And you can you kind of open up the joints, and that gives you more range of motion, but then that decreases the amount of surface area on the ball. So it's a balance of range of motion versus holding power on the ball. So it's just, you get the balance right. Asking Phil and the animators, they were basically just like, we're not exactly sure what the shot's going to be. Give us as much range of motion as possible. So I did that, but still it still has to hold together.
Now, Brett and Frank, I imagine you guys work together a lot because these armatures have to live inside the molds for the silicone and resin be cast around it. Can you tell me about that casting process once you take one of these armatures and put it inside here?
Well, when you design one of these molds, you have to design it with the armature being put in it in mind. So when you do this, the first thing you want to do is you want to be able to lock the armature down. There's screws down here where one of these armatures would be placed in here and bolted, and then it would be positioned just right. And so I had to work with him on where those joints actually happen. And a lot of these, they had to be adjusted a little bit. I think even though you match this, I had you change some of the dimensions just to kind of fit in the mold a little bit better. Same thing with the feet. Like, the feet need to be cut down a little bit to fit certain ways. And even like this little foot piece, like sometimes I'd ask him to make specific little pieces for wire armatures that I'd have to build for some of the other characters that didn't get the full ball and sockets. So once you position this first one, then you have to engineer the rest of the mold to close in steps so that you know that everything is in the right place. So this, I could put it in and I could see that the mouth is there, and then I could put just the top of it on there and check to make sure that it's not touching the top of the mold.
Right.
Same thing with the back. I can check all the pieces independently to make sure that nothing's touching.
And that was a trick. I mean, I spent a lot of time with the mold just after the whole armature was built, just positioning all the different joints. And it's kind of difficult because you can see, I mean, like I was saying, you can see up into the mold a little bit, but ultimately when the mold is closed, you can't see any of it at all.
You want it to be right in the middle, misaligned.
It's sitting in a cavity, but it can't be touching any of the walls. So.
Wow. In terms of the casting materials, I know the mold is silicone, as you said, but did you use different materials for the puppets as well?
Well, we just kind of jumped in on silicone, even though we talked about foam, latex, and other things. We jumped in with EcoFlex 0030. It was really soft, and it would give us that range of motion without being too stiff or being too sticky or anything like that. To cast silicone into silicone, it's just as easy as putting soap on there. If you feel the surface of this, it's still a little bit soapy.
Yeah.
That's it. You just scrub it down with soap and then put them together and inject it all in.
So they won't stick. So for this guy, hunk and big, you machine the armatures, Brett. But Frank, you had to also make some of the wire armatures for a really the small character like this, Violet.
When Phil originally did this, it was just a sculpture. So it was just a hard sculpture that didn't really move. Or no, actually this one was a hard sculpture that was just jointed with little wires. And so some of these parts we wanted to be able to move, like in the original, his fingers didn't move. So I would cast a wire armature inside of the silicone so that his hands could be posed, or so that his nose could be posed.
And it seems like so much of that is laying into the mold, so the wire isn't sticking out, and it's exactly where that bone structure should be.
In the center, yeah. With his machined armatures, it was real easy to kind of lock them down and get them in the center. When I had to do the wire armatures, it was a little bit trickier. With real skinny parts like this, I had to do it twice, which is why I have a second casting here. But also Sam, who helped me in the shop, she was really great at patching all the little, like on this one, little spots would touch through, and she would silicone seam it all.
Did you guys have to recast any of them after bringing one out, or was it all?
No, everything.
the first time?
We did, and this is a common thing with puppets. There were something went in a little bit loose, and we had to do some heavy duty surgery that is invisible now because it can be all sealed up, but it's like two sets of hands holding the skin apart, and another set of hands in there with an Allen wrench and cutting. And
I had to open up Big's whole back, and we replaced this whole joint right in here.
Wow.
But then you can all seal it back up, and it's as though it never happened.
And then you were also tasked with painting them.
I fortunately got to go over to the archives and see them in person. We all got to go over there.
It was a very special day.
And check out the puppets, and I took a bunch of reference photos and took some little Pantone chips to kind of get my colors right. Because as much as there was a lot of good photo reference, to see it with your eyes is a totally different thing. And I wanted to match it as accurately as I can. This is the chance to make sure that it's correct to the original. So we matched it, and I just started painting these things. I did a test paint on Crouch. This is just like a kind of messy casting. And we were toying around with replacing his spikes with stuff. But yeah, almost all these things I made, you could move that around if you want.
Wow, very posable. And so this is your test paint job. You worked on all 6 of them, and then that went back to the set for the animators to film. So we're gonna head back there right now and check those out. All right, Chris, so you have the puppets now. Frank and the team here fabricated, you got armatures underneath them. What's the setup like for filming?
Well, the first thing we do is talk to the stop motion animators and see what's comfortable for them. We need to build the dance floor. And I talked to Chuck and Gibby, and they gave me dimensions of how how high they want the table, where so they can lean over and they're not straining, going too high, or just hurting their back going too low. And once we have that, we went ahead and coated the table with black plastic. The original was done with velvet, so there were no reflections or anything. We wanted to take it a little bit further for this one, being that it's a brushed steel surface. We wanted to capture some of the reflections. So we got black plastic and tested the reflection on that, and then decided that it needed to be a little more brushed steel, so we spray painted it, used steel wool to get the reflections we need. Once we have that surface, we're able to line up the cameras so the characters are in the position they need to be in. And to do that, we drew out the schematic of the chess set.
Right.
And we use that to line it up to the plate.
And that's where we can see that actually this is much bigger than what the chess set looks like. They're like
Yes.
pop replicas of the chess set, because it's a bigger scale.
Yeah, the chess set on the actual Millennium Falcon has got to be smaller than this. The plates were already shot in 1977 or 76, whenever they were shot. And then George wanted to use one of Phil's puppets
Right.
and do it stop motion. He decided after it was already shot, so they couldn't make a chess set to the size of this puppet and reshoot. So that's where visual effects comes in. You shoot it on black, you can make them any scale you want.
And then for this production, for The Force Awakens, J.J. Abrams, his team, they shot a plate, you guys got the plate, and it's your job to do the compositing, to frame it up. And what did you do to what you got from Chuck and Gibby?
Well, first was the setup, and we used Dragon Frame, which is a really great tool for stop motion animation. You can load in a background plate, and you can screen the image over the background plate so you can tell if it's lined up or not. And what we did is we created a 2D piece of artwork of the schematic of the chess set, some concentric circles and then lines. And then in Nuke, compositing software, we took that piece of artwork, tilted it until it lined up perfectly with the plate. And then we were able to use that image of the 2D piece of artwork, bring it into Dragon, screen it over this table with the same exact
Same pattern.
and line up the camera.
Oh,
so
wow,
once
okay.
that's lined up, it's all good. Chuck and Gibby come in and place the characters where they want. And what we did is we tried to do a continuation of the original. So we placed every character where they were in camera from the angle from 1977. And then the angle in which the new one was shot, we had the camera set up for that as well.
Got it.
So we were able to just match it exactly. And then Dennis Murin came in and helped with the lighting setup, which is very simple. It's just a top light that's showered down, because sometimes when you think of a hologram, you think like very flat lighting.
Yeah.
But it was really cool because what Dennis wanted to do in the original is showcase the forms. So if you get the light just coming over the forms, they pop.
Now these are holograms, so they have to have some kind of holographic sheen. Was that also what you were in charge of?
Yes. So after it's shot, what you're hoping for is a black image with the characters on it, and with some subtle reflections that we wanted for this era. And we take those in, and originally they were just ND just over it, just like or DX'd over it, just a double exposure over it. And so that had a feeling to it, and we wanted to recreate that feeling. So we didn't do any fancy new glows and grid patterns and all this crazy stuff. We kept it totally like the original and did a nice simple screen. So the thing where you really get it is in the lighting and the practical feeling.
That's so cool. All that's the whole process, archaeology, the modeling, printing, fabrication, molding, casting, painting, animation, compositing, all for just a few seconds of one shot. That's pretty much an Easter egg. Thank you so much, Chris. And thank you to Mark and the rest of the team here at Phil Tippett Studio. And we'll have to watch the movie to see that shot.
Oh, I'm excited. All 5 seconds of it.